Hi viewers, welcome to my channel EDUTALK. This is Dr.S.Malligarjunan. I have been giving the engineering graphics lecture videos in both Tamil and English. In the previous video, Projection of Solids Part 1, we have seen the solid introduction and its first two positions. In this video, I will explain the third position with a pentagonal prism problem. Watch this video after watching the Part 1 video for better understanding. If you have not subscribed the channel yet, please subscribe and click the bell icon to get notified. Okay, let us move into the video. In this video, let us see the third position of solid. Axis is inclined to one plane and parallel to the other. It is difficult to imagine a solid when it is in this position. So, in this position, we have to draw the projections of the solid in two stages. In stage 1, the solid should be drawn in simple position. That is, the first position, axis is parallel to both the planes, and the second position, axis is perpendicular to one plane and parallel to the other, are called as simple positions. In these positions, axis is parallel to both the planes is a rare and a complicated condition. 90% you can't expect questions from this. Hence, the second position, axis is perpendicular to one plane and parallel to the other, is used for simple position. This one is also further divided into two subpositions. They are axis is perpendicular to HP and parallel to VP. Then axis is perpendicular to VP and parallel to HP. Once front view and top view have finished in stage 1, then we enter into stage 2. It represents the inclined position of the solid. That is, axis is inclined to one plane and parallel to the other. This third position also has two subpositions. They are axis is inclined to HP and parallel to VP. Then axis is inclined to VP and parallel to HP. I will explain this concept using a problem. A pentagonal prism of base side 25 mm and height 55 mm is resting on HP with one of its base corners, such that the axis is inclined at 50 degree to HP and parallel to VP. Draw the projections of the prism. To draw the projections, at first we have to note down the position of the given solid. It is given that pentagonal prism's axis is kept inclined to HP and parallel to VP. As it is third position, we have to draw the projections in two stages. In stage 1, we have to find the view that shows the true shape. Refer this table to find the simple position and the true shape position. For inclined to HP condition, the simple position is given as parallel to HP and the true shape is obtained in top view. You know that true shape should be drawn first in stage 1. So, you have to draw the top view first, followed by front view. Now, you know that top view is a pentagon. But in what orientation the top view should be drawn? There are many orientations. I will explain one by one. This pentagon is drawn by keeping its bottom edge parallel to XY line. This pentagon is drawn by keeping its top edge parallel to XY line. This pentagon is drawn by keeping its right edge perpendicular to XY line. This pentagon is drawn by keeping its left edge perpendicular to XY line. No edge of this pentagon is parallel or perpendicular to XY line. All edges are kept inclined to XY line. You have to choose any one orientation among these 5. Which one fits into our condition? Let us see. It is given that the prism is resting on HP with one of its base corners and the axis is inclined at 50 degree. So, it is necessary to rotate the prism in stage 2. If it is rotated in clockwise direction, then the true shape's corner should be in right. If it is rotated in anti-clockwise direction, then the true shape's corner should be in left. Hence, the position of the true shape's corner should be decided based on the direction of rotation of the solid. We should rotate the solid in clockwise direction in all problems uniformly. So, find which pentagon has the corner on its right. All pentagons have corners on the right except the third pentagon because it has an edge on its right. So, eliminate this. Now, you have to find the right orientation in the remaining 4. To find this, imagine lines that connect any two corners of the pentagon. In addition to these lines, there are edges that also connect any two corners of the pentagon. As a total, there are 10 lines which include 5 imagined lines and 5 edges. If any one of these lines is perpendicular to the XY line, then select that polygon. You can see that in this first polygon, no line is perpendicular to XY line. So, eliminate the first polygon. And in the second polygon, you can see the imagined lines and also the edges. Here also, no line is perpendicular to XY line. So, eliminate this also. And in the next polygon, you can see that the left edge is perpendicular to XY line. So, we can choose this. And the last one, here also no line is perpendicular to XY line. So, eliminate this also. The last thing left is this pentagon only. It is the one that satisfies the condition mentioned before. So, we select this pentagon to draw as top view. I have already explained how to draw a pentagon in projection of planes videos. If you have any doubt, please refer them. Now let us see how to draw front view and top view of the pentagonal prism. First, draw a reference line XY. Now you have to draw a pentagon with a side length of 25 mm below the XY line. The pentagon that we selected earlier is drawn by keeping its right edge perpendicular to XY line. In the same way, start with a line that is perpendicular to XY line and then draw the other edges to complete the pentagon. This is the top view of the stage 1. Let us see how to name this top view. I used alphabets to name the top base of the pentagonal prism as A, B, C, D and E. Similarly, the bottom base is named by using numbers as 1, 2, 3, 4 and 5. To get the top view, you have to look at the object from the top. When you look at the object from the top, you can see the top base A, B, C, D, E. Hence, you can see all the corner points on the top base. But you can't see the bottom base. That is, the corner points of the bottom base 1, 2, 3, 4 and 5 are invisible. So, you have to write the alphabets outside the bracket and write the numerals inside the bracket. So, for example, we can take the first point, that is A, and A is an visible point and 1 is an invisible point when you look at from the top. So, you can name this corner as A bracket 1. Similarly, the next corner, when you look at from the top, you can see the point B, but you can't see the point 2. So, this corner should be written as B bracket 2. In this way, you can write C bracket 3, D bracket 4 and E bracket 5. You have to locate the center of the pentagon in top view to draw the axis line in the front view. To do so, draw a thin line that connects the midpoint of any one edge of the pentagon and the opposite corner. Similarly, draw another thin line that connects the midpoint of another edge of the pentagon and the opposite corner. The intersection point of both the lines will give you the center point of the pentagon. Draw an axis line vertically upwards from this point. You know that axis line is an imaginary line that passes through the center of the object. It should be drawn by a thin line like this. That is, draw a long line, leave a gap, draw a short line, leave a gap, again draw a long line, leave a gap and so on. Project all corner points of the pentagon vertically upwards above the XY line up to 55 mm. Here 55 mm denotes the height of the prism. Whenever one view of the prism represents the true shape, then the other view's boundary must be a rectangle. Here the top view represents the true shape, hence draw the boundary of the front view as a rectangle. We know the height of the rectangle is nothing but the height of the prism, and we got the width from the top view. As I told you earlier, this is not a completed front view. We have got a boundary of the front view. The boundary lines must be visible. That's why we have drawn them using continuous thick line. But inside the boundary, we have two more lines. One is the axis line. So already I have explained what is axis line. So keep it as it is. And the next one, we have a thin line. This line may be a visible line or an invisible line. Based on its visibility, it will become a continuous thick line or a dotted thick line. Let us see whether it is visible or not. When you look at the object from here, you will get the front view. From this position, you can see two rectangular faces. That is AB21 is one rectangular face, BC32 is another rectangular face, and an edge which connects both the rectangular faces is nothing but B2. So B2 must be visible. It is positioned almost in the middle of the front view. So this line is nothing but B2. So B2 is a visible line. So you have to make it as a continuous thick line. So some of you are raising the question, sir, you are using a 3D model to explain. That's why you can easily explain. But we don't have the 3D model. It's very difficult to imagine the 3D model. So please explain with the help of this 2D front view and top views. Okay, I can understand your problem. Now I will explain how to find out the visibility of this line using this 2D top view. To get the front view, the observer is standing in this position to view the object. So that's why you can see the top view of the object here and top view of the observer here. The observer is standing here to look at the object to get the front view. So when the observer is standing here, his eye rays is passing orthogonally to the plane. That is passing 90 degree to the plane. Wherever it touches the object, those faces and edges are visible. Wherever they do not touch, those faces are invisible. Here you can see that the rays are touching this line and this line. Actually, this is not a line. In top view, it appears like a line. It is nothing but a rectangular face. You can see that AB21. What is AB21? This is AB21. AB21 is a rectangular face. It appears as a line in the top view. So similarly, BC32 is another rectangular face. It appears as a line in the top view. The observer's eye rays are touching these two faces. That's why these faces are visible. And B2 is an edge which is in the middle of these two faces. Hence, this edge is also visible. So make the line B2 as a continuous thick line, and then we get the front view of the stage 1. Let us see how to name this front view. Now you can understand that the vertical lines in the front view are representing the longer edges of the rectangular faces of the object. Similarly, the horizontal lines of the front view represent the top base and bottom base of the pentagonal prism. So bottom base is named by numbers. We can start from this corner, and from this corner, when the observer is standing here and look at the object, he can see these two faces. So all the points on these two faces are visible. That is A1, B2 and C3 are visible, and other points are invisible. So here he can see the point 1, but he can't see the point 5. Here also you can see that you can see 1 but you can't see 5. So this corner is named as 1 dash bracket 5 dash. Similarly, he can see the point 2 and point 4 is right behind point 2. That's why this point can be written as 2 dash bracket 4 dash. And here only one point is there, that is point 3. It should be written as 3 dash. And the top base is named by alphabets. So he can see A but he can't see E. So this top corner is written as A dash bracket E dash, and for this point he can see B but he can't see D. So you can write B dash bracket D dash, and the last one is only one point, that is C. So you can write C dash. Now let us see how to draw front view and top view in stage 2. It is given that the axis of the prism is inclined at 50 degree to HP. So when you rotate the non-true shape, that is front view of stage 1, you will get stage 2's front view. Front views of both the stages are same in shape and size except orientation. That is, here the object's axis makes 90 degree with the XY line, but here object axis makes 50 degree with XY line. Okay, how to draw the front view of the second stage? To do this, first you have to draw the axis line with an angle of 50 degree. After drawing the axis line, you have to draw the base edge followed by other edges. But in this method, it is somewhat difficult to draw the diagram. I will explain you some other method which is easier than the previous one. Now here, the axis line is parallel to all the longer edges of the rectangle faces. That is, this axis line is parallel to this line and this line. It means all these three lines make the same 50 degree of the axis, like this. Hence, instead of starting with the axis line, you can start with this line to draw the front view. Okay, I will explain. At first, mark a point anywhere on the XY line next to stage 1 drawing. This is one of the base corners of the prism which is resting on HP. It is named as 3-1 dash. That is, the 3 dash becomes 3-1 dash in stage 2. Draw a thick line from that point which is inclined upward at 50 degree with a length equal to the height of the prism 55 mm. The other end of this line is named as C1 dash. Next, draw one more line from 3-1 dash which is perpendicular to the existing line. The length of this line is equal to the width of this rectangle, and the other end is marked as 1-1 dash bracket 5-1 dash. Similar to this line, draw one more line at the other end of this line having the same length, and the line ends with A1 dash bracket E1 dash. Now close the rectangle. Now we have got the boundary of the stage 2's front view. We have to draw one more line. To draw this line, we have to locate the position of this line in this boundary. To do this, take a compass and measure the distance between the bottom corner and the position of this line. After measuring, keep the compass in the corner of the stage 2's front view and mark an arc. This is nothing but 2-1 dash bracket 4-1 dash. From this point, draw a line perpendicular to this line to get the line B1. The other end is named as B1 dash bracket D1 dash, and this is the required front view in the stage 2. But we cannot complete the front view without drawing the axis line. To draw this axis line, you have to locate the position of the axis line in this front view. To do this, again take a compass and place it at the corner and mark the distance between the corner and the location of the axis line. Then take it to the stage 2's front view and place it on the bottom left corner of the rectangle and mark the distance to draw the axis line. Once you have marked, then draw an axis line at an angle of 50 degree through that point. This is a line which is parallel to all these three lines. Next, to draw the top view in stage 2, project all the corner points of stage 2's front view downwards and project all the corner points of stage 1's top view to your right. Now, these vertical projection lines and horizontal projection lines are intersecting each other, and 10 intersection points are created, like the A line and A1 dash line intersect and create a point A1. B line and B1 dash line intersect and create a point B1. Similarly, we will get C1, D1 and E1. these alphabets represent the top base of the pentagonal prism. In the same way, you can mark 1 1, 2 1, 3 1, 4 1 and 5 1. And these numbers represent the bottom base of the pentagonal prism. We don't know the final shape of the top view. Whatever the shape, its boundary must be visible. It should be drawn by a continuous thick line. Hence, join all the outer points by a continuous thick line to create a boundary of the top view. This is only the boundary of the top view. We have to find the other visible and invisible edges in the object. To do this, the observer is standing in this position to look at the object to get the top view, and his eye rays is passing orthogonally to the plane like this. Now he can see the top base and this rectangular face. That is, the top base is visible because his eye rays is passing over this line. This line represents the top base. So top base means A, B, C, D, E. So join all the alphabets by a continuous thick line because the top base is visible. So already we have drawn two edges DC and CB, and draw the remaining edges by a continuous thick line. Now we have got the top base. And next one, his eye rays is passing over this line. It means this line is visible. This line means AE phi 1. It is nothing but a rectangular face. That rectangular face is also visible. And show the rectangular face in the top view using continuous thick line. So already E and A are connected, and join A and 1 by a continuous thick line, and 5 and 1 is connected, and join 5 and E. So this rectangle face is visible. Okay, have we completed the top view? No, not yet. Because still we have one more point, 3. Is it a visible point or an invisible point? 3 is a corner point on which the entire object is resting. And also the observer's eye rays are not touching the point 3. It means it is completely invisible. And one more fact is that all the lines connected to an invisible point are invisible. That is, the lines which are having a contact with this invisible point are invisible. And find the lines which are connected to the invisible point 3. And here 3 is connected to C. So join 3 and C in the top view by a dotted line. Next, check the other end whether 3 is connected to 1 and 5 or 3 is connected to 2 and 4. In this front view, it is not clear. So coming to the stage 1's top view, and here you can see the point 3, and 3 is connected to 4 and 3 is connected to 2, but the point 3 is not connected to 5 and 1. So join 3 and 4 by a dotted line in this top view, and join 3 and 2 by a dotted line in this top view. This is the required top view in stage 2. The front view and top view obtained in stage 2 are the required projections of the given pentagonal prism. So drawing is finished. You should use thick lines only for the drawing the front view and top view of both the stages. All the other lines and arcs should be drawn by thin lines. Don't forget to do dimensioning. In the next video, I will explain another problem in the same position, that is inclined to one plane. If you have not subscribed the channel yet, support me by subscribing. Don't forget to click the bell icon. By doing so, you will get the notifications regularly. Also, share this video to your friends. Thank you.